That's what I said.
So you're saying that now, but are you going to be saying that at midnight on Sunday?
No, absolutely not. But we could keep going after.
Yeah, we're 8 hours in, and according to the plan, we're about where we should be at like 5.5 hours. So we're way behind.
Okay, sure. Do you think we're ever going to get to play those math games?
Yes, we should be. There's one.
In the next 10 hours, maybe.
I think it'd be so cool.
So there's one scheduled in like 3 hours. We're not following the schedule, but like.
Well,
Basically, we're
yeah,
doing
probably 3 hours.
fractions, indices, and then a math game.
So probably 3 hours.
The schedule isn't prescribed, doesn't we have to go through everything?
No, we don't.
Could.
But we could. Honestly, at 36 hours, I'm gonna be so sick of it. I'm only saying this because it's like still below 23 hours.
How are we all
Middle of the
feeling?
way through.
You all feeling mentally stable?
It's not in waves.
Start with.
I don't know.
I'm
Like sometimes
feeling
I'm
as mentally stable as I did before, so I think that's good.
like I'll be crashing out for like a good 30 minutes. Like time bars, like what, free. And now I'm like, oh, this is fun.
Yeah.
We'll see how I feel when I get back from the concert, because I might have a horrible headache.
How far away is that concert?
It's in Salt Lake.
So you're gonna be like gone for multiple hours.
Yeah, so I don't know how. Because I emailed whoever's in charge of it, but it was like, hey, I have something to do today. It's like, is it kind of heavy? This that. And basically just said, I don't know if you can get a certificate, but also I don't know. I'll still use all the pictures and stuff. Like I don't think anyone, if I tell people I was part of a talent gift, anyone's gonna be like, show me your certificate. And if I pull up a picture and like, there I am in the left hand, I don't care. But also, as long as I'm not gone for 8 hours, I still can use these factors. So, and I don't think I'll be gone for 8 hours.
What an interesting pair. What do you think?
About what, sorry?
Perfect. Great. Oh, I think I'm only missing like 3 total people to my collection.
Yeah, really is like, I don't know people would have like 5, yeah. Nobody. There's still 23 more people. So maybe one person left. Yeah. That is
But,
I mean, sign up for 40 hours and that. You might not know what you're doing, but like you know you're insane.
how you feeling?
No, you're right.
The women's bathroom. You're sorry. Yeah, I think anyone contemplates what 40 hours every feels like, but to hear that number and be like, yeah, that sounds fine. You're insane enough. That's what I see how many people are sitting there. I'm a math
Yeah, and you're senior. Our friend went outside, but I think if I go outside, we'll start.
Heavy into math.
Oh my gosh, it will be dark next time. See, I think the no natural light down here is so weird. How was the outside? Hot stuff?
Cut you off from the paper supply.
Yeah, no, he's gotten into like a rip now. Like, I can predict his next words.
Yeah.
Sunday night, like his voice is for the next like.
I started writing down like a dictionary.
I think what's going to be
I won't be able to stop.
too stubborn.
So if it does come to that point, please stop.
I need to try to stay with you. Without in my head, I know God
Really? All I want is everyone to try it out. Not to brag. I will that. Okay, I do tiny things, but mine is like education where you get class.
I have all my classes and I finish my Friday. I walk
Okay, so welcome back. Welcome back. Let's continue with our fraction. We said our proper fraction is a fraction that has the numerator to be less than the denominator. And we gave some examples of proper fraction. Then for improper fraction is the opposite of a proper fraction. Then in addition, it is also a fraction that has its numerator greater than or equal to its denominator. Right? So meaning that an improper fraction is either greater than or equal to its denominator. Hence, 7 over 2, 8 over 3, 5 over 5. Give me more examples.
27 over 3. Yeah, that works.
27 over 3. One example from this side.
Just different numbers and words.
For improper fraction. 3 over 2. 3 over 2. So far the numerator is greater than the denominator, greater than or equal to the denominator. That's improper fraction. Maybe one more example. One more example. 42 over 7. Good. Then mixed fraction. Mixed fraction is the combination of both proper and improper fraction. So we have something like something mixed, a whole number 1 over 2 or 3 whole number 5 over 3. This is an example of a mixed fraction. Or maybe 7 whole number 2 over 3. Give me an example of mixed fraction. Give me
640 times the third.
40.
640.
Why do you like going very far? 640 whole number what?
A third. 1 over 3.
1 over 3. That's still okay. Okay. Maybe one more example.
5,325 over 1.
5,025.
And 7 halves. Nope, never mind, don't do that. 7 13.
7 over 13. That's still okay. This is an example of mixed fraction. Good. You know I invested the $100,000. We are doing something with our company. Okay, so now, how do we evaluate change from improper to mixed fraction. So if you have an improper fraction, and we are going to be mixed fraction, improper to mix. So if you have example, I will have 7/4. So what we are looking at is basically, we want to know how many times 7 can go into 4. So 7 can go into 4 one time. Well, it cannot go into 4 like the second time, it will not be complete. Hence, it will go into 4 only one time, only once. And what is the remainder? The remainder is 3. Hence, you have 3/4. Right?
Yes.
As simple as that. So if you have a number like maybe 10/3, how many times can 10 go into 3?
3 times.
It can go into 3 times and to have a remainder. Remainder was 1. It will still retain the denominator. Good.
Isn't it 1/3?
3, not 4.
Good.
There we go.
13/6. 13/6.
So you got
That's just how pure it is.
and 1/6.
Huh?
You have 2 and 1/6.
So 13 will go into 6.
Specific
How many times?
2.
2. 2 number remaining. What's the remainder?
1.
1/6. What about 3/3?
1.
To give you 1. And mathematically, you can see this as one whole number, 1/1, which is to give you 1. So mathematically, it's only written 1. Everything that is invisible is not written mathematically. Then how do you now move from maybe one more example. 21/2.
So that goes in 10 times.
So we have 10 whole number. 10 whole number. What's the remainder?
1.
1/2. Good. So this is a mixed fraction. This move from improper to mixed fraction. Now how do you take this back to maybe proper fraction? Mixed fraction to proper fraction. You simply multiply the denominator by the whole number. Then whatever you have, you add it by the numerator. Is that clear? Look at what I mean. We are moving from whole number to proper fraction or proper and improper fraction. You have to multiply the denominator. Denominator times whole number. Then you add whatever you get, you add it by, you add plus, let me say plus the numerator. So So here we have 4 times 1 will give you 4. 4 plus 3, 7. Hence here we have 7 over 4. What about here? 3 times 3 will give you 9. 9 plus 1. 10 over 3. 6 times 2. 12. 12 plus 1.
13
13
over 6.
over 6. Thank you. 1. 2 times 10. 20. 20 plus 1 will give you 21 over 2. Now addition and subtraction of proper fraction, proper mixed and improper fraction. Addition and subtraction of all of them. Okay, so if you have something like this, let's give the lesson from here. If you have maybe addition and subtraction of improper fraction, proper, improper, and mixed fraction. If you want to simplify the following. Simplify the following. So 1, we have 7 over 4 minus 10 over 3. 2, we have 1 over 2 plus 3 over 4. 3, we have 2 over 5 minus, let's say 7 over 2. 4, we have, we have what? 2 over 9 plus 1 over 3. Then 5 we have 7 over 11 minus 1. So, okay, from this, solution or solutions. So, from the first one, you find the LCM of the denominator. What's the LCM of the denominator? From the, how to find the LCM. What's the LCM of 4 and 3?
12.
Huh?
12.
Okay, 12. So what you do basically is, you use the LCM, you divide the numerator. Whatever you get, you multiply the, okay, use the LCM, divide the denominator. Whatever you get, you multiply it with the numerator. You add your sign, you do the same thing here. That's all, do your basic operation. So 12 divided by 4, 3. 3 times 7 will give you 21. Minus 12 divided by 3 will give you 4. 4 times 10 will give you 40. Times 10 will give you 40, yeah. So minus 21 minus 40 will give you minus 19. Minus 19 over 12. So you leave the answer this way. Or if you can, if you want to, you can change this to mixed fraction, but most times you leave it as a proper or improper fraction. Is that clear? So, number 2. We have 1 over 2. Find the LCM of 2 and 4, which is what? 4. 4 divided by 2 to give you 2. 2 times 1, 2. 4 divided by 4. 1 times 3. Hence, here we have 5 over 4. What about number 3? I want us to do this, pick up either number 3, number 4, or number 5. Let's do this individually, no, in pairs or in group. Let's take 2 minutes to simplify any of these. Number 3, 4, and 5. Just one, just do one of them, and you're okay.
You can help me.
So is this,
You have a minute more. You have a minute more. You are free to interact.
708.
So how many of you are done with at least one? At least 90%. Good. Good. So for number 4, for number 3, what do you have?
number 3,
What's our answer?
minus 31 over 10.
Minus
31 over 10.
31 over 10. Okay, who else got the same thing? Almost everyone. Good. What about the next one, number 4?
5 over 9. Yeah, that's the one.
1?
5 over 9.
5 over 9, okay. 5 over number 9. Did anyone get a different answer? Everyone got the same thing. What about number 5, the last one?
Minus 4 over 11.
Minus 4 over 11. Good. Okay, let's see. So, for number 3, the LCM is what? 10, right? 10 divided by 2, by 5 will give you 2. 2 times 2 will give you 4. Minus 10 divided by 2 will give you 5. 5 times 7 will give you 35, right? 4 minus 35 will give you minus 34. Hence you have minus 34 over 10. You can simplify this thing further. 2 will go cancel this. We'll have 17. Right? Here we'll have 5. Hence minus 17 over 5. Or you can read the answer this way, it's still correct. Then number 4. LCM is 9. 9 divided by 9 is 1. 1 times 2 is 2. Plus 9 divided by 3 is 3. 3 times 1 is 3. Hence we have 5 over 9. What about 5? Number 5. The LCM is 11. 11 divided by 11 is 1. 1 times 7 is 7, right? 11 divided by 1 is 11. 11 times 1 is 11. 7 minus 11 will give you minus 4. You return your denominator. So this is it. So we go back to the next topic. Indices. So indices is one of the fundamental topics in mathematics. I know you must have heard of indices, right? You must have heard of indices. So indices is simply the plural of the word index, right? So indices is simply the plural of the word index. What does index mean? Index mean forward. You can say it means forward, raised to power, or means you can call it exponent. Exponent. Or you can call it degree. Call it degree. Hope I'm correct, right? Degree, 4 degree, yeah. You can call it degree. So simply, this means the number of times a number is coming, like multiplying itself, right? Okay, so if you have a number, a base, number A, raised to power 5. What does it mean? Because in indices, what we do, we study numbers and the powers. That's basically what we do. And we do simplification using all the basic operations, all the basic knowledge of what we have done previously in mathematical expression, equation, all of that. So simply what we do in indices as a topic is study the numbers and the exponents. So everything here, this number here now, is the index, the power, the exponent, the degree. Then what this is called the base. Then what does it mean? This power means that the base is coming this number of times, which is equal to A times A times A times A times 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. What page? Okay. Means this A coming 5 times. This is simply the fundamental of what you need to know and understand about indices. Right? So this is a variable that represents a number. This could be any number. It could be 3. 3 raised to power 3 means 3 times 3 times 3, which will give you what? 3 times 3 is 9. 9 times 3 will give you 27. 27. Right? What about 2 raised to power 6? 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. Which is what? 2 times 2, 4. 8, 16, 32, 64. Is that correct?
Yes.
So you have 64. Likewise, any number. Even if you have something in parentheses, maybe A plus B raised to power 2. Just treat this as a common variable, that everything here is coming twice, which is A plus A in times A plus A. If you have this up to raised to power 3, it means A plus A raised to power the number of times it will be coming, right? When we get to this topic, binomial theory, we'll learn how to do some expansion using some method of binomial theory. We have the general expansion method, we have the Pascal's triangle method, we have the combination method also. So we not go higher, we not go so high at this level. We not extend the polynomials of the powers. We just keep it low and make sure we understand all the basics of indices. This is so fundamental. So, for you to solve indices problem, there are some basic rules and laws that you have to obey. You have some basic rules and some basic laws that you have to obey. So call it laws or rules of indices. So rules or laws of indices. So the first one is the multiplication. The multiplication rule or multiplication law. Which says that whenever you have two numbers of the same base multiplying each other, what you need to simply do is you bring them together and add the power. Hence, mathematically written that if you have a raised to power, let me write it here, a raised to power m times a raised to power n. This is equal to, you bring the base, since they have the same base, you subtract. So, I don't want to just give you this rule, I want to construct this in a way that you'll be able to understand and conceptualize all these things. Okay.
And then an add for multiplication.
I thought that this should be, this is plus now, I see. Correct, thank you. Thank you very much. So, now, if you have maybe A, let's say you have A raised to power 3 times A raised to power 3. What does it mean? It means this first A here is A times A times A. Is that correct? Times, let's this be A power 2. A times A, that's all. So if you count this number of A that you have A, 1, 2, 3, 4, 5. Which actually means A raised to power 5. But you notice that without passing through all this stress, if you decide to add up the power here, it will still give you the same thing. Everything equal to A power 3 plus 2. It will still give you what? A power 5. So this is the first rule. So wherever you see two numbers multiplying each other, having the same base, the variable could be anything. It could be any number, it could be any variable. Just like I told you that the variables are letters, they are representation of unknown values, and it could be any numbers. X, Y, A, B. Okay.
Is that monitor just off or did the timer?
The other.
Thank you. Okay. Is it working? No. Yeah. Okay, so this is the first rule or the first law. Then the second one states that for division law, then for division, division law or rule. It says that whenever you have a number, two numbers dividing each other, having the same base, the base is the same. You do what? You subtract the powers. As simple as that. Hence, if you have this a power m divided by a power n, this is equal to a power m minus a minus what? N. So you can see this mathematically from, if you say, let's say a raised to the power 5 divided by a raised to the power 3, right? So this means a raised to the power 5 divided by a raised to the power 3 means a raised to the power 5 divided over a raised to the power 3. You can write it this way. And we know that this numerator means a, and a. Therefore this, a coming 3 times. This you cancel this, this you cancel this, this you cancel this. Hence you have only 2 a's, hence a raised to the power 2. Mathematically. But you notice that from this, if you decide to just subtract here, you have a power 5 minus 3. That will give you a raised to the power 2. Yeah. Thank you. You can see how this is constructed. This basic rule. Let's give another example. Let's use number this time. Let's use number this time. So if you have like 2 raised to power 8, let's say 3 raised to power 7 divided by 3 raised to power 5. This implies 3 raised to power 7 over 3 raised to the power 5. Hence, 3 will come 7 times. So this is actually multiplication. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Then for the denominator, we have 3 times 3 times 3. 3 will cancel 3. 3 will cancel 3. Then this last 3 will cancel 3. What do we have left? And how many 3s do we have? 1, 2, 3, 4, right? Oh, this should be 5. So this also cancel this. This will cancel this. That means you're left with raised to the power 2. This is equal to 3 times 3, which is 9. Is that correct? If you decide to go straight using this rule, applying this rule. So, I don't just want to give you this rule. I want you to understand the way it works. So that, because sometimes, I don't want you to just go and cram this rule. Because me, I didn't even cram. I don't cram anything. Lecturer, I don't cram. You just have to understand the concept and how it works. Right? So that you'll be able to apply it. It's not even about the indices. It's about how you apply, how you'll be able to apply this to other concepts of mathematics. That's the most important thing. So applying this rule, you can see that 3 power 7 minus 5 is 3 power 2, which will give you 9. Good. The third rule is power rule. Power rule, which says the power rule, which says a raised to power m power n is equal to, all you need to do is just multiply. You know, we have been applying this, we have been doing this from when we did change of subject and mathematical expression. You have to just multiply this. You remember when we did square root, you just took square of both sides, so you'll be able to multiply and cancel 2. So it is from this law of indices. Right? So from here, you have a power mn. So this simply means if you have 2 power 3, 2. And this means 2 power 3 times 2. 2 power 6. Yeah? Or if you have 10 power 1 over 2 power 2. Okay, 10 power 2 power 1 over 2. This will multiply. This means 10 power 2 times 1 over 2. This will give you 10. Then one last example. 5 power 5 power 3. This is equal to 5 power 5 times 3 equals 5 power 15, which means 5 raised to power 15. So the next one is 0 index law. Zero index. So for 0 indexes, anything raised to power 0 is 1. It says if you have a raised to power 0 is 1. If you have 1,000 raised to power 0 is 1. 10,000 raised to power 0 is 1. Provided that that number is not 0. Because if you have anything maybe 0 by 0, infinity, right? You have to start talking about a different dimension. Provided, but there is a condition here. Provided that 0, that the number a, that number is not equal to 0. Any number raised to power 0 is 1. I think we can show this mathematically. We can use, let's use any of the example. X raised to power 5. So, a raised to power 0. Let's use a raised to power 0. Here, a raised to power 0 is the same thing as, let's do like a change of variable to do something. Maybe a raised to power, if I say this is equal to a raised to power 5 minus 5, is still correct? Because 5 minus 5 will give you 0. Am I correct? Right. Now, from this basic law, the previous law, where's the law? The division law. If you have subtraction here, that means you can change this from this to this. Right? So this could be equal to a power 5 divided by a power 5. And a power 5 divided by a power 5 means a power 5 divided by a power 5. What does it mean? This means a times a times a times a times a. 1, 2, 3, 4, 5. The same thing. A times a times a times a times a. A will cancel a cancel a. You have 1. So mathematically, you can see how this works. So I think it's very, very good that you are seeing all this stuff. Rather than having the memory that anything raised to power 0 is 1. Is there any other way you think we can show this? So mathematically, you can see that all these rules is applicable and it's not manufactured from Adam. Okay, so The next rule or the next law is negative index law. The negative index law. So, or the negative index rule. Which says that n raised to the power minus n is equal to 1 over a raised to the power n.